soon.
Fascinating. All right.
Okay. I guess it's being recorded. Cool.
Yeah. So one thing I
Yeah.
noticed with Codex was like for proofs, it would often replicate after just a few examples the style of the proof engineer, which is really cool. But it
Yeah.
wouldn't give you tactics that worked. But I don't know what it happens if you're inside of a
Yeah.
gigantic.
Are there any proofs in this file?
So this looks like it might be mostly definitions.
Yeah.
Yeah.
Although
Although it is interesting to me to see how it performs also with like Galena versus LTAC. Oh, an inductive expression. That might be interesting.
Yeah.
Okay. Inductive definition. Yeah, it's hard because I don't know like what meaningful information to add. What happens if you try to add a case? And just add a new constructor.
Oh, that's fascinating. Look at that. It's interesting. It sees struct and union, and it's like, why not array?
It's so cute.
Okay, now I think it's mimicking the previous. Oh, look at that!
T-array. It's a T-array.
That's so cool. That's so funny.
Does this make any sense?
I don't know. I mean, I don't know but it certainly did something.
Is T-array an actual constructor? I think that's something.
I don't think so.
Okay.
I think it just invented that by pattern matching this and being like, yeah.
Okay. It's really funny because it looks so plausible. But yeah, obviously, if you wanted to add that, you would have to add the right constructors and
right.
Yeah, interesting.
Another thing is,
it's just so interesting. Okay.
I want to find theorems.
Yeah, I don't know where the
actual proof.
I mean, here are some proofs.
Well, yeah. Okay.
Eventual eval sound.
I wonder if it will come up with complete as the second thing for sound.
Oh, I'm almost sure. Well, actually, yeah.
That's not.
Oh, that's just your autocomplete.
That's just the IDE.
Okay.
No.
Oh, interesting. Yeah, but I bet you after 2 of them it does. Like,
yeah, I forget what the next thing command is. Nope. Alt. Nope. Huh. Yeah, I don't know oh, this is the actual doc interpreter. We don't want to run that. Or proof checker. Okay.
Wait, so okay, yeah. Like I bet if you go down to list, it's gonna after one of those it'll try to give you a complete because all of these are gonna be sound complete. It's really good at picking up on those patterns.
Okay, let's check this one. Yeah, it knew that one.
Yeah, that makes a lot of sense to me. Did you save the? Okay.
Did I save the what?
Oh, the one that works, so that we know what was in CompCert. Okay.
Yeah. So I deleted the one that was already there.
Yeah.
And then I started typing out its name.
Yeah, I just want to see what it does for the theorem and proof and stuff. Does it have in the context things that are?
I don't know if it has things below and above or just above.
Yeah. Well, we should see. It'll be really suspicious if it gets it exactly right. So then we'd know it probably goes below.
So like here?
Yeah. Volatile. Yeah, I mean, so I would expect it to get the store complete. Yeah.
Yep.
Volatile storage chunk possible trace.
Yep, that's it.
Yeah.
Yeah.
Yeah, and then see if it gives you the same tactics. Because okay, so almost certainly it has.
Yeah.
Oh,
Yeah.
yeah. Uh,
No.
no. Interesting. Okay. Yeah, those are slightly different. Maybe the proofs were
Yeah,
just
it
that repetitive.
reordered them. It did these inversions before the next rewrite.
Yeah, so I bet you. Okay.
I just want to finish it and see if it. Okay, so that's what it came up with.
Okay. So can I look at some of these other proofs? I want to see if if they follow similar patterns like the other complete proofs.
Let me just comment this out.
Yeah. Like above, there were a bunch of proofs that were completeness. So like load, unfold, rewrite, find invert symbol, invert, rewrite, val of eventual complete. Yeah, so can we go back down to the one that was generated? Okay. So it was yeah, it was heavily basing it off of the volatile load complete in the context.
But it also could have been basing it off of the one that was directly below.
Yeah, I don't know if it had access to that or not.
Right. I
So
mean, it did.
yeah.
It did almost exactly this. So.
Yeah, but yeah, it's hard to know if it did that. Like,
Right.
yeah.
If it did
Um,
that on the nose, or if it did something like that, right? Like.
yeah. Because this looks a lot more like a lot of it looks like the load complete, but adapted to use store instead of load.
Mhm.
Um, val,
Right.
except use event val of val, which makes sense because the val store uses event val of val instead of val of event val. Like there is a really syntactic correspondence.
Mhm.
Um, I would believe it, I think, if it came up with this just from store
Right.
sound and the
What
load.
if I? What
Can
if
you run
I?
it?
What if I do this? What if we give it
I guess you
the
have to build all
theorem
of Concert.
statement? What did you say?
Oh, I think you'd have to build all of Concert, but I want to know if you if it if the proof goes through. But I think you'd have to build all of Concert, which might be slow.
And give it the theorem if it can come up with
Okay.
the definition. If it can, sorry, if it can come up with the proof. Actually, I don't know if this will put it out of its. Yeah, I don't really know of a way to.
I think it treats everything as text, so I would think that
Yeah,
probably it
commenting
doesn't
something out
understand
doesn't
comments. That it doesn't understand that comments are comments. I think they're just. Well, I
just
don't know.
text. All right, put that there. Delete it, and let's see if it can come up with the proof. Okay, that's what it came up with. Out the context, and then the actual thing is this.
What is the? Oh yeah.
This is the actual one.
Okay.
So this looks like exactly what it came
Yeah.
up with last time.
Yeah. It's an
Wow.
adapted version of do volatile load complete along the changes from do volatile store complete to do volatile or do volatile.
Store
From
sound,
sound
yeah.
to complete, from like store to load, load to store. It's
Right.
like there is a correspondence between the proofs, so it makes sense.
Right.
It's just funny that like the amount of that syntax. I really want to know if the proof checks,
Yeah.
but I don't know how long it will
I
take.
doubt I have all of the dependencies installed.
Yeah, yeah. Building Concert is usually fairly
Let's see.
like it's meant to be built nicely.
Take a look.
Because usually what happens is you get things that look really plausible but don't work. But with this much context, who knows? Maybe they'll start to work.
How do you build Concert? Um, make.
There's probably a README.
Yeah. Nope.
There's no README or anything?
Yeah, there was a README, but there was nothing in it.
Interesting.
Blah, 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 blah. Oh, my Lord.
I built concert before.
Make ball. There we go.
Yeah.
No. No. Drill to make target makefile.config stop.
Version license.
Let's do make proof. Yeah, it doesn't wanna. Let me look back at the website. License.
Do you use VS Code with Coq normally?
Yeah. Yeah.
Interesting. How do you find it?
There's how do you do what?
Oh, just like how do you think it? Do you like it?
I haven't actually like used it in anger before. Because I've never really been anger before, but like
Yeah.
I don't know. I think I'm taking software foundations this fall, so I will use it then and I will report back. But
Okay,
like,
you can. Looks like you can just do make all, but you
yeah.
might need to configure first. Do you have it? Is there a configuration file? Like /configure, and then you need to.
/configure.
You're gonna need to tell it
86.
your.
64. Just x86.
There's x86,
There's a help.
64, Linux, Mac OS, and Cygwin.
x86 64 Linux.
Yeah.
Okay, done.
Then you should be able to. Okay. It might make all, I think.
Yeah.
Just might be slow. I don't know.
Well, definitely doing something. So there we go. So the thing we changed was cexec.
Oh yeah.
Yeah,
Is it
yeah.
going to yell at you? Okay, no, I think it's fine.
If it's gonna yell at me, it'll hopefully yell at me there.
Yeah. Interesting. Yeah, it's a big project. So
Yep.
there are a lot of things to build.
Let's see.
I love that it captures the proof engineer style though, because this is something that the proof automation that I write always struggles with. Like, I do all this fancy stuff over proof terms. I can update your proof terms in response to, really like some complex changes. And then we try to get you back up to proof scripts, and the proof scripts don't resemble the original proof scripts yet. So we're working on like a decompiler that's actually using like a neural network to try to suggest and rank tactics based on ones that are actually likely, for
you. Yeah. What?
But the U part is hard, and like the U part seems to be much less hard with these gigantic models where they can just, it's interesting. It's fascinating to me. I mean, there's some hope in the future. I think that you can get both.
What sort of things are like indicative of a proof engineer's style? I guess I don't really know what the different styles of using Coq are.
Yeah, I would say a number of like custom tactics that people are using. So like some people will use super heavy custom automation. Some people will, like Xavier, who wrote Concert, he has a pretty manual style. You'll see he uses like, a lot of like.
I mean, this is rewrite,
these are all
rewrite,
tactics.
inversion,
Inversion.
These are built-ins.
Yeah, it's very, very low level and simple. And yeah.
And I know, like, Adam is very fond of incredibly complex automation and things like that, right?
Yeah, Adam will use a lot of complex or like custom tactics.
Right.
That's one part. I don't remember. I feel like that's the biggest dimension along which people vary.
Mhm.
There's also even things like their frameworks, like SS Reflect,
Right.
right, and like that comes with its own gigantic chunk of like weird tactics that,
Right.
um, yeah, uh, and a specific way of doing proofs. I think I don't know.
It's got a whole other syntax and like idioms, right? It's like very
Yeah,
yeah.
yeah.
Let's see. Extraction. It's here. Oh, this is just. I see. It's not interesting. Oh
What happened?
no,
Oh,
I'm just interested in the. Oh Lord. Yeah,
these proofs are intense.
that's a lot. That's a pretty tremendous proof engineering effort.
Yeah, it's true.
I guess I don't know. I never like I always knew it was huge, but I've never actually looked at it before.
Yeah, yeah. This is why I was interested in like concert of any project. I'm like, if you're gonna pick a like Xavier has a distinctive style. Like he wrote so much like code and so many proofs and like um
Right.
it'd be interesting to see. And I think it's actually fairly plausible to me that it does somewhat well on Xavier's style because it's like another dimension of style. Like
Mm.
things like whether you refer to variable names explicitly, or whether
Mm.
you use like
Wild card, like
or
underscore.
there's the whole like structural tactics thing that came from like the Verdi people, and there's this struct tact um, like library, and what it does is like it so the tactics were in there are like instead of depending on the names of variables because if the name if anything changes like automatically generated names will change for example.
Right.
So what they'll do is like just depend
Ah,
on the
hold up. There we go.
Yay.
Okay. So it's
Okay.
wrong.
Yeah,
Good.
yeah, they'll depend on the structure instead. um okay, so this is really interesting though. Does it let you step through now?
Yeah,
um
it's a good question.
like can you see the
Yes.
context? Yeah, this is so cool.
I actually don't know how to jump to a place, so we're gonna have to wait for a second.
Because I'd be curious to see
Okay, cool.
if it like sometimes when you get closer, sometimes when you get close, it's like harder to finish it off yourself than to just do it from scratch, and sometimes it's not. It'd be interesting to see how well it does.
Oh, that's interesting. So we get an equation from
Yeah,
H6, and then there's nothing matching it in the body.
right. Yeah, because it was just parroting the parroting. um,
Yeah.
large language models.
Yes.
Yeah, it's parroting the other proof where it did a similar rewrite. So what happens in the real proof?
Yeah, that's a good question also.
Yeah.
Let's this one. So the step was after that. Well, it's slightly different, but let's see how it goes.
Yeah. Okay, so the beginning is just completely the same, which is cool.
Identical, identical,
That's like
identical.
boilerplate, right? Yeah.
Same. Okay, this doesn't happen
So they did a
until
rewrite. Okay, what happens if you add that rewrite before rewrite H9 above?
yeah. Let's see.
Just curious. If we just move that rewrite, like maybe if it was just off by a distance of one, I'd still be impressed. Um,
This is like proof. It's like delta debugging the output of Copilot, which is very fun.
Yeah, this is debugging these things is one of the most interesting things to me, I think.
Okay, now does H9 does go through.
Okay, so now remove the second
okay.
rewrite. Yeah.
Now that will delete that because that just happened, and then auto done.
It got really close.
That's so impressive. Wow.
Okay.
Wow. So I mean, it's
That's
basically
how repetitive things are. Yeah.
Yeah.
It just So I mean, I feel like it do really well on Xavia's style because he specifically writes things in this low-level way that exposes like the names of every single hypothesis and like makes it very explicit. And so like I would expect Xavia's style to be really, really good for like priming something like this. But yeah, I feel like a big Atom project would be my next try. Big Atom project might be fine too because he also uses these he'll probably reuse a lot of these high level tactics.
Right. And like if the abstractions are chosen well, then they should sort of carry between the different cases of the proofs in a similar way that the syntactic structure of these carries between the different cases.
Yeah. Yes, and then maybe the only it might just be hard in the sort of middle ground there. It'd be interesting.
You want to try an Atom project?
I don't know if we should try another project or another proof.
Okay, let's do another proof.
Okay, yeah. Maybe try a different location in the code because I don't know, just for fun.
Yeah, that was. I want to do another proof. That was really cool.
Yeah.
Let's.
And we can try new I don't know. It's hard to write new content for someone else's code. Right. I don't know what I'm doing.
What about is the parser? No. There's no cock here.
The .v files all are.
Yeah. What about there's probably some interesting non-syntactic stuff in the code gen. Sure, constant propagation. Are there theorems or is it just definitions? Just definitions. CSC. Wow.
Yeah, it's amazing.
It's really remarkable.
CSC proof.
Oh, wait, where's that?
All of these have separate proof files.
Oh, proof files. There we go.
Yeah.
My computer is taking off at the moment. Okay, cool. Nice. So, yes. With the Copilot written proof, we've just compiled Certicock. Not Certicock. Yeah.
Yeah, we just had to rearrange two tactics. That's pretty impressive.
Yeah, that's well done. Okay. Where to? Ooh. This is a big one.
Oh my god.
Let's see what it can do.
Okay.
So sometimes one thing that I've noticed is that if it starts to really get lost, it'll just repeat the same thing over and over.
Oh yeah, this is a huge problem. So this is a problem with Codex itself, I think. And I don't know. So I heard GPT-3 also does this, and there's a way to set a penalty to for repetition. And I don't know if Codex has a repetition penalty kind of thing that I can do or not. Because then you can stop it from getting caught in those death loops.
Yeah, it's just, yep. Here we go.
There we go. It's a death loop. Yeah. Yeah. It really needs the repetition, some repetition penalty thing. Yeah. Yeah. I asked them about this and I don't know. I wanted to know the technical reasons and they just gave me something about how this is what these models do sometimes. And I was like, oh.
That's how language models work. We don't really know.
I'm sure someone knows the answer to that.
Right. I mean, can you really like probe the internals of a language model that well to understand why it gives you what it does?
No, but you can understand what things you change that make it not do the thing.
Oh, okay.
So, I'm gonna see if there's. I'm looking at the Codex API, like just the playground, to see if there's a way that I can DaVinci Codex. Up to
Oh, it really likes this.
what is stop sequences? No. There's a frequency penalty. How much to penalize tokens based on their existing frequency in the text so far? Yeah, okay. Probably the frequency penalty if you could increase it.
Yeah, I don't. Let's see.
It would be in Codex. I don't.
Oh,
do
okay.
you
Yeah.
have like options or?
Yeah, Copilot does have options,
It's
but
worth
I don't know how
seeing.
much it's. Where are the options? Autocomplete count.
Inline.
Yeah, no. Those are all the
Interesting.
options.
They don't let you like.
They don't let you actually
the
twiddle with the
literacy model.
underlying.
Okay. Fascinating. Yeah, I feel like. Yeah, if we could change the frequency penalty, which by default seems to be 0, then we could at least work around that behavior for now. I don't know what it does when you, I want to know why it does that thing, but it's interesting. What are you looking at now?
No, I don't know. I'm just sort of. Oh, I'm back in the.
Oh, okay.
Here's the CSV stuff.
Cool. Yeah, so we get problems with.
Right. Yeah, and also like one thing is that when we did this, when we cut out this whole thing, it didn't do anything like what the start of the proof even was. Right. The first start of this is unfold, intros, destructs. Blah, blah,
Does
blah,
it have your whole project in context or just the things above it?
I think just the things in the file.
Okay, so what if you go lower and like do another gigantic proof, but like later in the file?
Okay. What about like?
Oh my god!
Oh my god!
Xavier!
How do you not? Oh, that makes sense.
The simulation proof. Wow, that's an intense proof. Okay, I mean it's a normal. I think it's a proof that usually follows kind of established patterns, but
yeah,
I want to make it try simulation. I'd be curious.
Sure. This can do if it works. We're about to blow all of compiler correctness research out of the water.
All you need to do is have Xavier prove one compiler correct.
And then you can just train your neural net on it and spit out a bunch of new compiler correctness proofs. Okay, what you got? Okay. Nope, that's what we're currently proving.
Oh no, that's bad.
Now it's just going to list theorems that we.
Okay. So we have an idea. I think when you have lots of small, and this makes sense. I think this is in line with what I've heard of Copilot and other things.
Mm-hmm.
When you have small functions, or like just codex performance in general. So when you have small functions or proofs, or like where you give it a lot of context and there's like a lot of similarity, it does pretty well.
Right.
Gigantic novel things, no.
Right. I mean, it was shockingly good at doing this, of which there were 15 other versions, all slightly different.
Yeah, and that's a common kind of scenario though with proof engineering. So it's like it does seem like it could be useful in that way.
Yeah. I mean, unless this is one top-level induction that has to be done in a big loop, one could think of splitting this into a bunch of smaller lemmas for each case, and then maybe it would be more help then. Although sometimes that doesn't work just for logical reasons, obviously. But
yeah, what happens if you start the proof? Like, you give it the one of the cases like inop, because it might use the comments too. Yeah, it should use the comment.
Oh, what if I give it and the comment? Yeah. Well, let's start it. Let's start it here.
Okay.
I don't know, just picking. Or maybe should we give it more context?
I don't know. We can see. We can. Yeah, I mean, you can always see if we can get the last couple cases for you.
Yeah.
I have no idea what these are.
Doesn't auto like try to terminate the?
Yeah, but I think Xavier writes proofs without bullet points, so auto would probably handle cases. What is this?
Is that correct? Is that syntactically?
I have no idea what's going on.
Well,
that's probably
definitely
right.
doing better.
Yeah, I mean, it's writing tactics now. I'm very skeptical about the intros in the middle there. Not that I have any idea what's going on at all.
Right. Neither do I. But
yeah.
I mean, what if we try to?
Can you compile down to?
Yeah. How do you?
Oh, you don't know how to. Okay.
Yeah, I don't know the.
I don't use.
Yeah, no, neither do I.
VS whatever.
What's the? No, I don't want key maps. I want my key bindings. Keyboard shortcuts. Interpret 2-point, alt right arrow.
The alt right arrow.
That was fast. It's impressive. Does it? Let's see. Oh, very first one.
Okay, yeah.
Yeah.
So what about some of the? Yeah, I don't know. How much context did we give it?
Not a ton. Let's try doing the very last.
Yeah, just curious. I would expect it to struggle with these kind of novel proofs where most of the file has been building up the infrastructure to do them, and there isn't another example that really is similar to it.
Spam call from Fresno. No. What? So what was the first thing? He applied. So inv stack. Let's give it that.
Interesting.
What's the next thing? Deconstructor split. Yeah, no.
Okay, yeah, it's just going to struggle too much with this.
Yeah, still, yeah. There's not enough similarity between the cases, I guess.
Yeah, it's interesting to me. I feel like I feel like this should be possible from a proof engineering perspective, not with this approach, but conceptually, because the correspondence between the cases maps exactly to the correspondence, usually, but like the correspondence between the constructors. Right. And then there's some extra, like novelty.
Lemmas that you've already proven that you have to call out to at certain points to do whatever, right?
Yeah. So like in a semantic model, like where you have access to more than just text, I feel like you could do something like this. But I understand why this is hard. This is interesting to me because this means, I've been thinking about in our model whether I should include the constructor and case numbers when I'm building things. And to me, this is yes, because like textually, yeah, I think that's one of the only ways that the correspondence will show up. And I think
Right.
it's literally just, yeah, it's just not in this data because we don't have well, yeah, maybe, I don't know, it also doesn't understand that does it pick up on the fact that these are all cases?
Right. I don't know if it knows that one single dash means okay, new case. Right.
Yeah,
Yeah, I think maybe the case number itself. Did you say that as one of the things to carry as in the data?
yeah, I mean, that's what I'm thinking. Like that's what we
Mhm.
might do. Yeah, I've been considering it. Um, yeah, we're definitely going to keep around names of everything because the syntax seems to be really helpful. Or
Mhm.
at least maybe not. I don't know about variables at first, but I mean, in tactics, obviously variables in
Mhm.
Galena terms. I don't know yet, but like constants and types and constructors and so on.
Mhm.
I think we want the names. Actually, the constructor names are not in the AST in Coq by default.
What? How?
Uh,
What is it? How does it represent them?
it's just a number that maps to like the offset and the inductive type, and then I'm pretty sure that the name you have to look up from some other environment somehow.
I
Yeah,
believe. I mean, that's probably a good compact representation.
I
That's
think
like.
it is. It's just yeah.
Yeah.
So some of the other models that will parse uh, Coq into an AST are going to miss out on well, I guess it depends how much of the environment they represent. But I think if they don't include the global environment,
Mhm.
there will be no proxy for constructor. Now this is raw text, so they should have constructor access, but there's no understanding of how they map to each other.
Right. Of what a constructor is. Right.
Yeah,
Yeah.
yeah, yeah. And another thing about that is like, yeah. So if it had constructor number, it would
Mhm.
also have the type, the inductive type.
Right.
Um, And then when you induct over something, you'd be inducting over like that particular type when you break into cases.
Mhm.
I feel like if you include the numbers, it should do pretty well. Almost like, yeah, it'd be kind of funny. A fun experiment would be like just like literally by typing things in here, like how could I augment all the code to like
Mhm.
make Copilot just way better? Like what do I tell it in the comments? Like
Right.
I don't
Yeah.
yeah. Um Cool. So this is good for me. I know that numbers are good,
Yeah.
or like probably good numbers. Well, I don't know what else to try. Do you have anything else you
Yeah.
want
No,
to
I
try?
don't. I don't have any thoughts.
Um,
Yeah.
yeah.
Cool. This was really fun,
Yeah.
and I
Yeah.
hope useful for you.
It was cool. Yeah. I kind of want to just like, how do you feel about just posting the recording? Like,
Yeah.
it's up to you because I mean, you have my consent for that, but
Yeah. Sure.
yeah.
Put the recording where.
I don't know. Like, I mean, just like because I was thinking about a medium, and I don't feel like writing a whole text thing.
Mhm.
I feel like people would kind of like just the video, unless there's
Yeah.
anything that
Sure.
you said that you're not comfortable with. So
No, that's totally
cool.
fine.
Yeah, maybe just like YouTube it. Just like, how does Copilot do on Coq? I don't know.
Yeah. No, that's a good idea. Yeah, I can.
Proof
I'll
engineering with Copilot.
right. Yeah, I'll have to look through it and make sure everything is good, but I would be totally fine with that.
Yeah, that'd be cool. Yeah,
Cool.
you recorded, so I think you have access.
Yeah. Let me stop the recording.
Okay.
Stop. A link will be added to the event, and everybody in the guest